Fluorescent lights can generate static in radios due to several factors. The primary cause is electromagnetic interference, or EMI. Fluorescent lights generate high-frequency electromagnetic fields that can interfere with radio signals. Another cause is poor grounding. Improper electrical grounding can allow static to build up on the light fixtures or wiring, causing interference. Ballast issues can also be the culprit. Faulty ballasts, which are electrical devices that control the lights, can generate stray EMI. To address these issues, there are several possible solutions. Firstly, improve grounding. Ensure that all electrical outlets and light fixtures are properly grounded. This can be checked by a qualified electrician. Secondly, install EMI shielding. Wrap the fluorescent light fixtures with metal foil or conductive fabric to shield them from EMI. Thirdly, use shielded cables. Replace the cables connecting the lights to the power source with shielded cables that minimize EMI. Fourthly, choose appropriate lighting. Opt for fluorescent lights with lower EMI emissions. These typically have electronic ballasts and better shielding. Fifthly, replace ballasts. If the ballasts are suspected to be faulty, have them replaced by a qualified electrician. There are also additional considerations to keep in mind. One is antenna placement. Position the radio antenna away from fluorescent lights to reduce interference. Another is other devices. Check if other electronic devices in the home, such as televisions or microwaves, are also causing interference. Dimmers can also be a factor. Dimmable fluorescent lights may generate more EMI than non-dimmable ones. Consider replacing dimmable lights with non-dimmable models. The cheaper under-cabinet fluorescent lighting may not cause static because firstly, they may have lower EMI emissions due to their smaller size and less powerful ballasts. Secondly, they may be installed in a location that is farther away from the radio. Thirdly, they may be using shielded cables or have better grounding. However, it is still possible that even these lights could contribute to static in certain circumstances, especially if they are installed incorrectly or malfunctioning. When addressing electromagnetic interference from fluorescent lighting affecting radio reception, a systematic approach is crucial. Begin by examining the grounding system throughout the house. Ensure that all electrical outlets and light fixtures, particularly those associated with the fluorescent lights, are properly grounded. An electrician can use a grounding tester to verify the integrity of the ground connections. Inadequate grounding can create a path for EMI to propagate, exacerbating the static in the radio. Next, consider implementing EMI shielding techniques. Wrapping the fluorescent light fixtures with metal foil, such as copper or aluminum foil, can act as a barrier to contain the electromagnetic radiation. The foil should be properly grounded to dissipate the captured EMI. Conductive fabric, specifically designed for EMI shielding, offers a more durable and aesthetically pleasing alternative to foil. These fabrics are typically made of interwoven metal fibers and can be cut and shaped to fit the fixtures. Shielded cables play a vital role in minimizing EMI transmission. Replace the existing unshielded cables that connect the fluorescent lights to the power source with shielded cables that incorporate a layer of conductive material, such as braided copper or aluminum foil, around the conductors. This shielding effectively blocks electromagnetic radiation from escaping the cable and interfering with the radio. Opting for fluorescent lights with lower EMI emissions is a proactive measure. Look for fixtures that are specifically designed to minimize EMI. These lights often feature electronic ballasts which generate less EMI compared to traditional magnetic ballasts. They may also incorporate built-in shielding mechanisms. When selecting replacement ballasts, prioritize those with low EMI ratings. Manufacturers often provide specifications regarding the EMI performance of their ballasts. Consult with a qualified electrician to ensure that the replacement ballasts are compatible with the existing fixtures and wiring. If the existing ballasts are suspected to be faulty, replacing them is essential. Faulty ballasts can generate excessive EMI, contributing significantly to radio static. An electrician can diagnose the condition of the ballasts and recommend appropriate replacements. The placement of the radio antenna is critical in minimizing interference. Position the antenna as far away as possible from the fluorescent lights. Experiment with different antenna locations to find a spot where the static is minimized. Consider using an external antenna that can be positioned outside the house or in a less interference-prone area. Rule out other electronic devices as potential sources of EMI. Televisions, microwaves, computers, and other electronic gadgets can emit electromagnetic radiation that interferes with radio reception. Turn off or unplug these devices one by one to see if the static diminishes. If a particular device is identified as a source of interference, try moving it farther away from the radio or using a power line filter. Dimmable fluorescent lights often generate more EMI than non-dimmable models. This is because the dimming circuitry can introduce additional electromagnetic noise. If the dimmable lights are causing significant static, consider replacing them with non-dimmable alternatives. Evaluate the possibility that the cheaper under-cabinet fluorescent lights may be contributing to the problem, even if they appear to be less problematic. These lights may have lower EMI emissions due to the smaller size and less powerful ballasts, but they can still generate some interference. Inspect the wiring and grounding of these lights to ensure that they are properly installed. The distance between the fluorescent lights and the radio significantly impacts the amount of interference. The farther the lights are from the radio, the weaker the EMI signal will be. If possible, relocate the radio or the lights to increase the separation distance. Shielded cables and proper grounding can help to minimize EMI even in cheaper fluorescent lights. However, the quality of the shielding and grounding can vary significantly. Inspect the cables and grounding connections to ensure that they are properly installed and functioning effectively. If the static persists despite these efforts, consider consulting with an experienced electrician or an EMI specialist. They can use specialized equipment to identify the sources of EMI and recommend more advanced solutions. Advanced solutions may include installing EMI filters on the power lines, using shielded enclosures for the electronic devices, or implementing more sophisticated grounding techniques. Always prioritize safety when working with electrical systems. If you are not comfortable working with electricity, hire a qualified electrician to perform the necessary tasks. Turn off the power to the circuit before working on any electrical components. Use appropriate safety equipment, such as insulated gloves and eye protection. Double-check the wiring and grounding connections to ensure that they are properly installed and secured. When selecting replacement components, prioritize those that meet or exceed the original specifications. Use high-quality materials and components to ensure long-lasting performance and reliability. Properly dispose of old or damaged electrical components in accordance with local regulations. In summary, addressing radio static caused by fluorescent lights requires a comprehensive approach that encompasses grounding, shielding, cable management, and lighting selection. By systematically addressing these factors, it is possible to minimize EMI and improve radio reception. Continuous assessment and iterative improvements may be needed to achieve optimal results. Understanding the nature of electromagnetic interference and its interaction with radio waves is critical for effective troubleshooting. Electromagnetic interference is a disturbance caused by electromagnetic radiation emitted from various sources, including electronic devices, electrical equipment, and natural phenomena. This radiation can interfere with the normal operation of electronic devices, including radios, causing static, noise, or other distortions. Radio waves are a form of electromagnetic radiation used for communication. When a radio receiver picks up a radio wave, it converts this into an audio signal that we can hear. However, if EMI is present, it can disrupt the radio wave, making it difficult for the receiver to decode the signal accurately. The strength of the EMI signal and the sensitivity of the radio receiver determine the severity of the interference. Strong EMI signals can completely drown out the radio signal, while weaker signals may only cause minor static or noise. The frequency of the EMI signal also plays a role. EMI signals that are close in frequency to the radio signal are more likely to cause interference. The distance between the EMI source and the radio receiver is another important factor. The closer the source, the stronger the EMI signal will be. Conversely, the farther the source, the weaker the signal will be. The presence of shielding can significantly reduce EMI. Shielding materials, such as metal foil or conductive fabric, can block electromagnetic radiation from escaping or entering an enclosure. Grounding provides a path for electrical current to flow back to the source, preventing the buildup of static electricity and reducing EMI. A well-grounded system can significantly reduce EMI. Understanding the factors that contribute to EMI is essential for effective troubleshooting. By identifying the sources of EMI and implementing appropriate mitigation techniques, it is possible to improve radio reception and minimize static. Regular maintenance of electrical systems is crucial for preventing EMI. Inspect wiring, grounding connections, and electrical equipment to ensure that they are in good condition. Replace any damaged or worn components promptly. Keep electrical equipment clean and free of dust and debris. Dust and debris can act as insulators, increasing the risk of static buildup in EMI. Stay informed about the latest EMI mitigation techniques and technologies. New and improved methods for reducing EMI are constantly being developed. By staying up to date, you can ensure that you are using the most effective techniques to protect your electronic devices from interference. Remember, addressing EMI is an ongoing process. It requires continuous assessment, monitoring, and adaptation to changing conditions. By implementing a comprehensive EMI management plan, you can protect your electronic devices and ensure reliable performance.